we're going to talk about data management. And we're going to tag team this again. So myself, Sean, and Shane, we are kind of professional nerds as well as drone fans. So we've had a lot of experience. And between the three of us, we use different sets of tools and we have different styles. So we don't claim to be the experts. I don't think anyone's an expert in data management. This is an evolving field. New tools are coming out. Everybody's grappling with it. Every time I go to a conference, this is a common theme. Like somebody raises their hand and say, could someone help me manage my data? So it's important about it. We're going to chop this session up into 3 parts. I'm going to introduce the topic and try to make a case why you should care about this. Then Shane is going to review some of the tools in the ArcGIS platform, of which those have evolved a lot in the last couple of years. And that's one widely available platform that many people have access to and have some good tools that can be used. And then Sean's going to walk us through a case study of what our group has done internally for the whole pipeline, from landing the drone to, delivering the final results. So why should you care about this? Well, drone data are large data, and we're not just talking about the images, right? So the images are relatively, they're important, and you can land a flight and have 100 gigabytes worth of JPEGs or TIFF files that you have to work with. But once you start processing those, as you probably have already seen, your data expands dramatically. So this is a kind of a sketch of general project sizes for different areas of hectarage. There's a lot which this scatter plot does not show. It doesn't talk about the resolution or the type of sensor, but as a general principle, the trend is up, and the trend is up dramatically. And you can even just look at the very small projects, right, in that first part of the column. I mean, you can have a small project that's still going to be like 600 gigabytes. That's maybe a couple acres or something like that. So data is large. Here's another way to kind of visualize that. This pipeline, if you remember that Candyland graphic at the start of the workshop, we tried to come up with another graphic here that shows how much data are you dealing with as you do your drone project. From mission planning to data acquisition, flying the drone, it goes up a little bit, but it really, really goes up once you start stitching those data together. And if you look at your file sizes, whether you're using Pix4D, Metashape, ArcGIS Pro, you'll see there's some, it can grow up by a factor of like 5 to 10 easily. And then after that, you're probably still going to do more work, right? You're probably going to create some indices, maybe do some visualizations. So data is something that you have to be cognizant of, right? As much as we wish we wouldn't have to. And really, it's only when you get all of those pieces that you get your final results. And it's not just the size of the data that makes this a huge headache. It's also the variety of the data. Yes, you've got your images, but then you've got lots of other spatial and other types of data that you need to keep track of. Your flight logs, possibly. If you're using ground control points, you've got data for those, the coordinates of those. You might have ground sample data, right? So like you've measured plants, or you've measured volumes or soil types or something like that. You may want to keep your telemetry files, right? There's important things. Oftentimes you're taking other photos. Yes, you've got your photos from your drone, but you might have photos of your calibration targets. You might just have sort of general reference photos. You may take some videos with it. Quite likely you're going to have some base map files when you're developing your site, or maybe planning the maps that you're going to combine with your drone data. You probably might want to keep track of the image center points, right, which we saw as part of the photogrammetry software. And then you've got the 5 or 6 flavors of the outputs, your orthomosaics, your elevation surfaces, point cloud, maybe, if that's important for your work, maybe a mesh quality report. That would be a good thing to keep track of. And then you may have metadata files, which we'll talk a little bit more about that. So it's a lot of types of data, and it's a big volume of data. So one approach is to use one of the drone data servicing platforms. One of these, I call these one-stop shops, because many people, as we saw yesterday, will use, Pix4D Cloud or Drone Deploy. They'll get the subscription service. And one of the reasons people use these are really popular, is because they stitch the data for you, and you don't have to go through all the headaches of doing it yourself. But the other thing that these service providers handle for you, which is a huge benefit, is they manage all that data in the background. You get a nice, clean dashboard to design your mission, maybe on a tablet, maybe on the browser. And then you have another nice, clean, user-friendly dashboard to look at the results and share the results with your friends. So these types of platforms, and this might be where we're all going, right? Most of these are commercial-oriented, but there's some that are coming up that are more science-focused. Some of these are focused around specific industries like Slant Range. They're big in the ag world. Drone Deploy does a lot of construction work. Some of them are tied to specific hardware. Some of them are not. Some of them are fairly expensive. Some of them are not. But anyway, so this is one approach to managing your data. It's let somebody else deal with it. And if the dials and levers that they expose for the stitching process, if they meet your needs, then a lot of people would find this an attractive proposition. And we're not reviewing these. We don't really have a whole lot of experience with them. But feel free to put in the chat window if you have any endorsements or other thoughts about various cloud-based platforms. If you want to do it yourself, and this is kind of what we're focusing on today, because A, we're academics, and in the research world, we want to see more of the dials and levers. We want to use Metashape or Pix4D. So we tend to do more on our own on our local machines. But these are the challenges you're going to have to face, maybe not all at once, but eventually you're going to have to face, where am I going to store my data, right? Just a basic fact, you know, it's large volumes of data, right? You're going to put the cloud on your desktop. How are you going to organize it, right? So you can find what you need. And you're going to probably be working with this data in different contexts. How are you going to document your data, right? So that's like everything else about who was the pilot, were there clouds that day, all the things that you can't just extract out of the images themselves, right? Who was the PI? What was the research question? Why was this choice made? And so on and so forth. How many flights were there? The formats, you have to think about that. There are a lot of standard formats, and the GIS software mostly use those formats, but that's important to think about. Transferring data is not trivial, right? If you want to put the backups on the cloud, and then you have an external hard drive, and then maybe some other platform, you have to think about how you're actually going to move the data, because just dragging and dropping gets old really quickly. Quite likely, you may have to worry about privacy and or data security, right? If you're doing contract work for a PI or it's research data that you can't release right away, or maybe not at all, you have to think about those things. How are you going to share your data and the results with your audience, right? That might be a client, might be a research journal. And then finally, how are you going to back it up and archive it, both in the short term as well as the long term? Do you need versioning? If you are going to back it up for the long term, do you want to keep everything or just the final outputs? Sean's going to talk a little bit about what we've come up with for our unit. All right, so let's go to a poll right now. So if someone could start our Zoom poll, the question for you is, if you're working with drone data, where are they right now? This was inspired by those public service announcements back in the 80s, where they would say, do you know where your kids are right now? So for those of you who are working with drone data, go ahead and check the boxes. This should be a select all that apply kind of question. And where are your drone data as of right now? And we'll give this maybe 10 more seconds, and then we can stop the poll and look at the results. All right. Oh, that's very interesting. All right, so it looks like local computers and external hard drives are the winners. A little bit less so on the cloud storages, but also part of that. And the local network drives, few people using ArcGIS Online, not a whole lot, and then a few people aren't quite sure where their data are. So this is pretty typical, right? I would say this is probably a distribution that represents drone mapping in general, right? Everything starts on a memory card for the most part, but from there, we tend to work with it locally on computers and maybe external hard drives. All right, thank you. I can stop the question. All right, I will pause in a second for questions if somebody can keep track of that. So the cloud systems there's a lot of these out there. Probably everyone here uses one or more of these. They are good. They tend to be cheap. They tend to be fairly accessible. It's important to remember that these are file-based systems, right? So you're actually saving files on these various platforms. So it doesn't take all the pain away from you. You can basically use this as backup. So if your computer explodes or gets stolen or something like that, there is a backup. Your data still need to be organized for these to be effective platforms for you.
Hey, Andy,
Okay.
someone had a question about who owns the data when they're stored on the cloud.
That's why there's a big question mark next to that. I guess technically you do, but that doesn't mean you're the only one who has access to it. I think Sean has probably thought about this and worried about this more because he does projects where the data ownership and sensitivity is part of what needs to be. Any thoughts, Sean, on who owns the data? If you upload your data to Dropbox, for example, maybe for backup, do you own it or does Dropbox own it?
Technically speaking, I believe you still own it. They're just providing a service to host it, but that's that doesn't mean that it can't be accessed by them internally. The thing is that I haven't heard of this coming up as a problem. It's more along the lines of someone having a keylogger that gets into your data via that method, and that's the greater concern usually.
Yeah, but these are important details to think about. Same would apply if you're going to put this on your, say, your university file storage system, right? Think about who has access to it, and is that going to meet your needs? Some of the tools for, kind of the generic tools for organizing data, right? Because as we talked about, directory trees, that's a really tried and true technique, applies to all kinds of projects that are data-centric. I'm not going to talk through this one. Sean's going to look at it a little bit later. But the point is, using directory trees within your file system, within your computer, is a great way to keep data organized. There's different approaches to doing this. The various folders that you create might organize a clump of data by the project. Sometimes we will put in by the data type. So like maybe all the multispectral data images will be in one branch of the tree. You might think about categorical relationships. So think about what kind of directory structure works for you. General best practices is that we're trying to minimize the amount of redundancy, which has a cost, and also plan for growth, right? If it's not a one-off project, think of a directory structure that will work for your needs that you can expand and continue to use. And we'll see an example of how we've done that in a little bit. Another sort of generic tried and true practice for organizing files is to develop naming standards and stick with them. And there's a few tricks here. If you're going to name files using different parts, so a naming standard, commonly you might have the date at the beginning of the file name, and then one or more keywords to talk about the project or the location or the equipment. Sometimes part of the file name is a version number, right? That can get clunky, but it is a technique that you can use. General best practices, use a consistent standard. Standards aren't standards unless you actually are consistent. Avoid special characters, especially spaces, not as big of a deal breaker as in that, but sometimes you hit tools that have problems with that. Try to keep your file names concise. Use abbreviations. So like for a project code or a location code, use a little abbreviation and try to be consistent. We've gotten some pain when we have been less than consistent. And try to keep your file names on the short side, right? There's a few programs, Pix4D being one of them, that has where you can hit a max when you hit 256 characters. I won't talk through the example file names below, but there's different styles. Some people like camel case, some people like snake case. Putting the date first is a good way because then they sort nicely when you look at them in your browser, and so on and so forth.
And just as a GIS
do you have any favorite?
Just gonna say, just as a GIS person, I would try to avoid being like shape 1, shape 2, shape 2A. I mean, that's kind of why Andy's getting at this point.
Yeah. All right. File formats is something else that you need to think about. That's less of a big deal than it used to be. The spatial file formats, TIFFs, and shape files, that's fairly standard right now. You need to think about your coordinate reference system, like are these data projected or not? You may have to do some manipulations for that to work. And this is what you need to have a good spatial alignment. And we'll see some more examples. I guess one thing I would highlight is that the Esri's geodatabase, which is now the default format, for ArcGIS Pro, that's not an open source platform. You can read from it from open source tools like R or Python or maybe QGIS, but you can't write to it unless you have that Esri license. To be cognizant of that and maybe make a different choice if you're going to be working with the cross platforms. How you share your data, right? There's some more choices here. This is just 2 of probably a dozen different options, but 2 that if you did the step 0 exercise for ArcGIS Pro, you had an experience to look at open aerial map. That's kind of a community driven. Performance can be iffy because it's, it's just being done by some donors, but that's one platform that people can use to share their drone outputs, at least orthomosaics, with the world. ArcGIS Online is one that we're going to look at here, and then there's some others. Our group has developed some tools to facilitate some of these gymnastics that you have to do with your data. I'll give a shout out to my R package. There's a GitHub site. It's on GitHub. This is not a stitching program. It doesn't see statistics. It's really like a data cataloging, data management, has features, does those lightweight HTML pages. So if you go to our DroneCamp program, click on the more data link, you'll see some examples of the type of output it can produce. Nice, user-friendly. You get to see the flight area. You see some graphs about the GSD and the height. It has some other features. I'm not going to talk about this today, but if you're interested, let me know. We can set up another time to talk about those things. One function I will highlight, because I don't know any other tool that produces it, is that if you have a single drone image, like a single TIFF or a single JPEG image, and you want to put it in your GIS map, you need to create a world file for it, and this is something that this package can do. If you just plop it on your ArcGIS Pro or QGIS, it might pop up as a little marker. It might be ginormous or minuscule. So creating that world file will help with that. We've also developed some Python tools. Sean's going to talk about a recent Jupyter Notebook Python tool that we've developed to create a directory structure, essentially. And then we've got a couple others, one that ran on the laptop in the field, and as soon as you put your SD card in your laptop, it would suck all the images onto the laptop, put them in that directory structure, sometimes even start a GIS project. And we've got some more details. If you click on that link there, we did a poster last year where we talked about some of these open source data management tools that we built, including one of our colleagues. Lastly, let me talk about some of the gold standards. Repeatability, if you're in science, this is becoming more and more of a standard. Hard to do with GIS and hard to do with photogrammetry, because as you've seen, it's a lot of point and clicking. But if you do need repeatability, that often means writing scripts. There are platforms, Metashape being one, ArcGIS Pro. I don't know if ArcGIS Pro supports photogrammetry with stitching, but they do have enterprise solutions. And then Pix4D has a command line system that you can use as well. Making data findable, accessible, interoperable, and reusable. This is a much larger movement. It's a set of initiatives that across science data in general. There's a big community. There was a nice paper that came out around this time last year, specifically looking at making drone data fair, because as you know, unlike the satellite companies where there's maybe 5 or 6 satellite companies who are collecting satellite images and organizing it nicely and making it easy to find, the drone world, it's tens of thousands of people are out there, and it's, there is no platform. What I really hope to see, maybe in a couple of years, is that this photogrammetry software will actually make this easier for you to at least share your data, at least give you the option. Once standards are developed, if we can make the tools easy to use, provide incentives, because right now the incentives are quite low, and provide training, I think this will help us get to making our data fair. So let me pause there for one question, because I've talked a little bit longer than my 10 minutes, and then before turning it over to Shane. And if Shane or Sean, if you see any germane questions, otherwise we'll keep going, because we've got some more stuff to cover. All right, Shane, I will turn it over to you then.
Okay.
And you say next when you want me to keep going.
Will do, Andy. Well, good morning, everyone. My name is Shane Feirer, and like Andy said, I'm going to quickly discuss sharing and managing data with ArcGIS Pro and ArcGIS Online. One thing about ArcGIS Pro and ArcGIS Online is they are tightly coupled. Esri really wanted to use their desktop platform and ArcGIS Online platform together with each other. So within Pro, you can access ArcGIS Online data. Within ArcGIS Pro, you can also push data up to ArcGIS Online. So it's really nice in that regard. Today I'm going to quickly talk about some of the sharing options in ArcGIS Pro, some of the limitations, and then hit on a few, and these limitations and these features will hit on some of the things Andy highlighted, such as storage, organization, security, backup, documentation, sharing, and automation. So almost everything Andy talked about is what we're going to try to quickly chat on here today. Andy, next. Okay, so within ArcGIS Pro, and we'll talk about this later today if you're in my ArcGIS Pro session, on the ribbon on the top of the program, you can go to the sharing tab. And there's a bunch of features in here to allow you to share your data with others and backup data and such within ArcGIS Pro. If you go in there, what you're going to see is that you have a package section, a share as section, which is really a way to create web features, web services. You have a save as group, you have a print functions, and your map export functions. All of these tools are really set up so that you can share your data, you can back up your data, and you can organize your data. So let's quickly go in and let's talk about these individually a little bit more. Next. So if you were to go into the package group, which you see here, actually you probably can't see my mouse because I'm moving it, but it's not working obviously. If you go to the red box, which is the package box, this allows you to go in using ArcGIS Pro, and you can back up and make a compressed file of your data. If you do a project package, it takes your ArcGIS Pro package, all the data, all the styles, all the maps, all the layouts, and it creates a package file of all that information. So it makes one file that you can share, you can store on your computer, or you can share and post up to ArcGIS Online. And once it's on ArcGIS Online, you can set security on it, so only you can see it, only members of your organization can get access to it, or everyone can get access to it. So it's an easy way to get your data out there and to get your process out there and what you worked on out there. We use this quite often, at least I use it quite often for backing up my projects and keeping them on my local machine. So that's the project package. There's also a map package. So within a project, you can have multiple maps. You can actually zip up or make a package of just your map, and your map would contain the data sets that are referenced in it, the styles that are referenced in it, and any labeling and everything else that's in that map itself. So it's not the complete package, it's not the complete project, it's just the map that you're looking at. And once again, that can also be shared to ArcGIS Online or saved to your local computer. And the file that you do save to your local computer could be shared on things like Google Drive, Dropbox, Box, any of those systems as well. So then we have several other options. We have the mobile map package. This is something that's relatively new. It allows you to take your map and your mapping data, your base maps, any custom imagery, like if you had an image, processed image from drone data, you could load that into a mobile map package, share it to ArcGIS Online, and then bring it into your mobile mapping applications from Esri and actually work with your drone data out in the field and work with it offline out in the field. So it's actually really quite nice in that way. Then there's also the layer package, which allows you to take an individual layer from your map, save the symbology, save the labeling properties, any definition queries that you've defined on that layer, and save that and share that out. Really quite nice. All these packaging options really make it so you can store your data, organize it, secure it, and back it up. It's really, really some nice features. The other two options I really haven't discussed much is the geoprocessing package and the deep learning model package. I haven't used the deep learning modeling package at all yet. It allows you to save if you're doing a deep learning model within ArcGIS Pro, machine learning, deep learning, you can save that package and share it, and then others can then download that package and use it in their modeling efforts. The geoprocessing package is really nice because you can do all your analysis get it so that it's working properly, and then you can share that up to ArcGIS Online or to your enterprise server within Esri. And then you or other people in your organization can use that workflow in their projects, in their ArcGIS Pro, and get the same results you get. So all these things in the package sections are really nice for sharing and organizing data. Then that takes us, next slide, to the share as functionality within ArcGIS Pro. One thing I should mention is this toolbar is responsive, or it's, I guess responsive will work. Depending on what type of data you have in your data frame or within your table of context, it'll give you different options. And if you notice here that you see web scene above web map, that is because if you're in a web scene, you have an option to share a web scene. If you're in a scene, you have an option to share a web scene. If you're in a map, you have an option to share a web map. So the thing about the sharing tab, it's really a way to share your data and your maps directly to ArcGIS Online, and you can share them as an interactive map or an interactive 3D scene similar to Google Earth, where you can navigate around in 3 dimensions. That's what a scene is. You can share them as individual web layers. So if you had one layer that was really important that you wanted everyone to have access to, but you may not need them to have everything that's in your map, you can just say, share this one layer up to ArcGIS Online, and then it becomes available to you and your organization, or if you flag it, to everybody. It's actually really quite powerful in that way. Then there's a couple other tools that you can do. You can share styles. So if you work for an organization and you have a lot of different colors, standardized color palettes for branding that you're supposed to use on your maps, on your symbols, on whatever you produce cartographically, you can create a style in ArcGIS Pro, and then you can share that up to your organization, and then everyone can use those styles that you've developed so that all your maps have the same look and feel. And that's something you can post to ArcGIS Online by using the share as a web style. The other two features are really, you can create a custom locator. If you're familiar with location services or locators in ArcGIS, you can go in, you can use it's basically a geocoding service. You could type in an address, it'll tell you where it is on the map and zoom you there, but it may not have your company or organization or very specific things to your research. So you could actually have all your plots out in the field. You could create a locator. You could share that to ArcGIS Online, and then people could find your plots if you wanted them to. They could type in the name plot 5, and it would take them to plot 5 of your research. So it's really nice that you can share your locations as well. And then the web tools, being able to share a web tool is you can take, like I said before, with the geoprocessing package, you can share that package of all the tasks and histories of the analysis steps that you've done. With the web tool, you can share that as a tool that someone can click on and actually run that from ArcGIS Online without having to actually have the GIS software on their machine to run that analysis. So you're basically packaging up the data and the processing steps and pushing it up to the web, and then you can run the analyses from there. So the packaging and the share as tabs are really nice for getting information out there and getting your workflow and your data out. I use the share as all the time with the work I do. So now let's quickly talk about what most people think about when they think about GIS, and that's cartography, saving data, not saving data, but saving cartography, exporting data other than to the web. So Andy, if you can go next slide, please. So if we go to the Save As group on the Sharing tab, you will see the ability to share projects, maps, and layer files. These are the symbology and the layout and structure of either your project package, your map file, or your layer file. So if you've created a nice looking map within a project and you want people to have that same look and feel and data structure, create a project template and you can share that within your organization. If you want to have the same map for same look and feel in your map, your same base maps, the basic data structure, you can save it as a map file and send that out to your team as well. Another thing that's not on this exact example here is a layout file or layout template. You can actually have a cartographic output that you've created in ArcGIS Pro which is a map with a data frame or a map frame, legend, scale bar, all the things you'd expect to see on a map. You could save that out after you get a really nice looking cartographic product. You could share that within your organization or within your team, and then everyone can use that template to get the same look and feel. The layer file, you probably, if you worked with GIS and you've worked with Esri products, this is something you're probably all familiar with, where you can save the symbology and anything else that's applied to that layer. You can save it as a layer file, and then you can bring other data in. It doesn't even have to be the same data set, and you can apply that layer file to it, and it'll then have the same look and feel. And you may have to change like what the labeling field is, but everything will come over and you can use it in your mapping packages. So it's actually really nice. I use these things mostly for reproducibility and for quickly firing up a map that I may have to do for someone that they always want the same look and feel, or they want their data to look the same every time. And that's why I use the Save As tab. And then if you go to the Print tab, this one, Andy, next please, is pretty self-explanatory. It's print. You know, it's a really basic thing that we've been doing in GIS for 30 years. You create a map, someone asks for a paper map of it, you print your paper map and you give it to them. It will print to any of your printers that you have access to on your local device, or if you've got network printers, you can print to those as well. It's really just print, set your settings, and hit go. There's not much else you can do with it, but it is a way to share your information. Next slide. Then that brings us to the mapping tab within the sharing, within the mapping group within the sharing tab. With this option, you can export your data, you can export your map, and you can save them as file formats that you can print, you can send to people, you can send to public publishers, you can send it to people who are doing publications for you, like newsletters or anything like that. You can produce the data in many different formats, whether it be vector formats or raster formats. There are some caveats to using the mapping function. Not every file format works the same. There are some weird idiosyncrasies with exporting data from ArcGIS Pro. And that is that if you, let's say you print a JPEG, you may find that for some reason it doesn't print a vector layer. You can drop the roads layer, won't show. You could then print it as a PDF and it works fine. You could try to print it as a PNG, another layer may drop out. So you want to make sure when you're using these tools that you export the data out, verify that it exported properly before you just assume that and send it off. And if it doesn't export properly, you can try changing your dots per inch, your DPI, or change a different file format. One other really important file format in the export map is the PDF format. You can create GeoPDFs that are spatially enabled, and you can also create map series PDFs. So if you were to implement a map series using ArcGIS Pro, unlike every other file format that you can export to, PDFs can actually take advantage of those map series. So you could have 30 different map series or 100 or 200 pages in that map series. You can export your PDF so it has each one of those or a select set of those map pages inside of that PDF. So it's really quite powerful. So this is a really important tab in ArcGIS Online. It's really how you share things. So if you don't mind, Andy, next slide. So what we really just talked about was sharing the cartographic output, sharing the data sets, sharing the project packages, sharing the underlying data. And we briefly talked about geoprocessing packages and web tools. But another thing that Andy had mentioned was automation and repeatability. And one of the things with ArcGIS Pro is that they've really embraced the use of Python, and they have their own module, ArcPy. And within this last release of ArcGIS Pro, they've actually integrated in now Jupyter Notebooks. So you can open Jupyter Notebooks right directly within Arc Pro. You can write Jupyter Notebook script. You can save it and then reuse those within your projects. And if they're stored in your project, you, as far as I know, when you do a project package, they get stored with that package. So it also goes with you. And I actually really love, I'll admit this, Jupyter Notebooks. They revolutionize repeatability and being able to reproduce maps, data, everything with just the click of a mouse. And ArcGIS Pro is making it easier to integrate with these systems. So you can you can always create a Jupyter notebook. You can email that to somebody. You could store it to the cloud, but you can also recreate that now. Next slide, please. Within ArcGIS Online, within the last, I would say within the last year.
I wanted to give a quick shout out, Shane. So the Esri User Conference will be online in about 3 weeks. It's free to anyone who's got a license, which is most educators and others. I saw on the agenda, they have a session on the new Python tools. So check that out if you want more.
Oh, fantastic. Yeah. And if you don't have user agreement in place, a license agreement in place, the plenary sessions are free. So if you want to at least listen to the plenaries, I think normally there's one at the user conference. I think this year they're going to be spread out over several days. So please check out the plenaries. They always show you the newest and greatest. So definitely check it out if you can. One thing I wanted to point out, so now Jupyter notebooks are integrated into ArcGIS Pro. They've also, if you have an ArcGIS for organizations, an ArcGIS Online for Organizations account, they've also now made it so that Jupyter notebooks are part of ArcGIS Online, and you can host Jupyter notebooks directly from ArcGIS Online with GPU support, all the machine learning libraries built in, so you can very easily recreate your workflow on ArcGIS Online and save that out and share that with people using ArcGIS Online. One thing I did point out though, when I was talking about sharing web maps and web scenes, is when you go to share your data from your map, especially if you're dealing with drone data, and you go and you have your drone data in your map and you go to share it to a web scene, it is going to basically create a tile service of that drone data and push it up to ArcGIS Online. You can't work with the underlying data. You can't change the symbology. You can't work with the underlying pixels with ArcGIS Online. That's a limitation of ArcGIS Online as of right now. The workaround for it is you need to have an ArcGIS Online, and that's right, ArcGIS Online. You need to have an image server stood up. And with the image server, you can share your drone data to the image server. You can make it so you have pixel access, which allows you to actually use the analysis tools directly on the data that's being shared off the image service. So you can do things like NDVI calculations, hill shades, all the stuff that we'll be showing you this afternoon. You can do that with image services. Also, you can create custom metadata that goes along with the information. And all the data that's shared on an image server can be brought into ArcGIS Online as well as ArcGIS Pro. And what you see on the screen right now in front of you is just a subsample of some of the data that we're serving off our image server of all of our drone flights that we've done around the state of California. This is actually where I'm located, up in Mendocino County in California. And we've had, I want to say it's 7 to 8 different projects, but we have flown, God, what is it, Sean? 4,000 acres at least?
Well, Hopland alone was.
Yeah, I mean, just that Hopland alone, at least 4,000 acres.
Around that.
And what you can do, and as you can see here on the left-hand side, this is within ArcGIS Online. You can click an image and you can see the metadata for that image that we've added. So you can see when it was flown, what sensor was flowing, and also where it's stored on our server, so we know where it resides. And you can add a lot of other information as well. So this is a really powerful tool. But if you don't have enterprise GIS set up with image server, it's difficult to share your data, at least your drone data, using ArcGIS Online. Trying to think anything else? I think that's it. I'll turn it over to Sean so he can talk about that project more and also managing our drone data.
Hey, yes, thanks, Shane. Yeah, and I'm going to rapid fire these some of these slides. Just as a note, I have a lot more slides than I would possibly be able to cover in 5 minutes or so. This was done intentionally because I know that all of you are going to have these slides available to you in the slide deck for download, and some of the, particularly the file structure slides at the end, might give you some information that you'd be interested in. So what I'm going to cover is the actual pipeline, the resources for the data management, a couple resources, specifically a Jupyter notebook that can be imported into ArcGIS Pro that will make your data management much more easy. And then some solutions for big data and scaling up your operations. I mentioned before, I'll mention again maybe, one of the goals of DroneCamp is to give you the things that I wish that we had when we first started. And among all the things that I can think of that are the most important that could have saved us the most time would be efficient data management. It seems like one of those, I don't know, boring subject, but starting off, you don't know all the different ways that you can arrange your data and how this big data is going to, I know, clog up your computers, laptops, desktops, your hard drives, your cloud. And there's systems that you can use that will make it standardized and more efficient. Next slide. So we created this Uber graphic of the entire pipeline of how this process can go. Next slide. Oh, just one slide up. Back one. There you go. There you go.
There?
Yep, that's it. Trying to get my, I can't do it. Trying to get my Zoom window out of the way of the text. The pipeline of the drone management that we have, we developed it over a number of years now and kind of cleaned up some of the sharp edges. Next. When you collect the data, the first thing you'll end up with is a whole bunch of images on your card that you'll have to put into your computer. We use Tix4D, but it depends, whatever photogrammetry software you are going to be using will be expected to absorb that data. And sometimes they spit out their own file structures. Next. So this is where the data management really kicks in, is right from the beginning. I recommend you start organizing your data there, because we've found, especially when we're doing kind of enterprise operations with a team that's all over the state collecting for different projects that have different objectives and different people with different naming conventions. Later on down the pipeline, all of this becomes rather inconvenient to try to reorganize it in a way that's both, back to Andy's slides, discoverable, easy to communicate to either collaborators or clients. And so there's having a standardized workflow or a tool, even better, to set your data up right from the beginning out in the field is a really good thing. Next slide. So we've created a couple of these tools in-house. One, the second one on this pop-up is the Python package that Andy has on GitHub for parsing out data, giving yourself a quick view of the ground sample distance, the footprint on the ground. That's one tool that can be used. Another one that is really handy is a Jupyter notebook inside of ArcGIS Pro, which I'll come to at the very end of this presentation. And we have tech notes that are available too. One of the things I do really strive to do, and we all do for our drone camps, is just to add value to every new drone camp. And this tool alone would have saved me way more than the cost of coming to the drone camp in time and hours, opportunity costs of time spent on other things that could have been more important. But having a script that will create an entire directory structure with metadata infused into it is really handy. Next slide. Just a note, some platforms and their workflow have their own proprietary software that kicks out their own unique file structure, and these have to be reorganized manually, usually into your other automated file structure. And this really gets drone dependent in a lot of cases. And so that's why it's manual. If you use one platform over and over again, then that's fine. You can have a script, but that does that for you. But if you're using multiple platforms or switching it up with new generations, makes it difficult. Next slide. So one of the things you got to do in the field is do a quick quality control check, maybe using Andy's parsing drone images Python script that's on GitHub, among other things. Next slide. We usually use Pix40 Mapper for that, by the way, just to test to make sure everything is right there and in the correct places, and maybe run the rapid processing option just to check to see if it'll stitch initially.
Checking for blurriness is part of that.
Oh, good point. Good point. I don't want. Yeah, I shouldn't pass over that. Yeah, checking your images yeah, that can be an issue. Yeah, so when you leave the field, again, your images should be in a file structure. And just as a side note, don't lose your hard drive or your computer. Maybe even back it up in the field so it's both on the memory card of the drone and on your hard drive. So it's at least in 2 different places, because accidents happen and that will ruin a long data collection mission. Next slide. Then comes the office component where you plug in your data in your computer, run your processing, usually on a local computer, because pushing your data up and pulling it back from the cloud for processing becomes kind of processing like a little bit time prohibitive, but that's another option. But we usually run it on a large Alienware computer that's ideal for this kind of processing. Next slide. So sometimes you also have to account for the fact that you have to process your Trimble files, for example, your GPS files, and format them correctly to fit back into your photogrammetric processing software. Next slide. Then you have, in the processing, as Andy kind of got to, you can create up to 10 times as much data as your original data that comes out of your drone, which ends up being already to start with pretty large, but it gets much, much larger in that step. Next slide. Next slide. Like I said, I'm going to rapid fire through this stuff. I just want to touch on the key points here for the sake of timing. When the project's done, we usually back it up onto a desktop hard drive, something like a Buffalo drive with 20 terabytes of data storage in a RAID format. And then from there, because it takes a long time to push it up to the cloud, we'll set it up overnight or over the weekend to move projects up onto our either cloud or the server. Typically our server, the way our infrastructure is set up. Next slide. Oh, and there we can sometimes delete our intermediary files, the middle files, in the process of doing so. Then you'll end up having a whole bunch of core files on your server. The way we have arranged our server, we've set it up with raster analysis with essentially different systems running within the server for analysis, for manipulation, for your GIS image server for web applications, so it can be served up in the way that Shane was talking about, and then having it connected through Open Portal. And this is all set up through a data store as well. Next slide. And then this would be a different visual of how this might be arranged. In this case, we have a 30 terabyte storage. And then because we have eliminated a lot of the intermediary files in the processing and kept some of the metadata, the original images, and the processing setup the way it was arranged, as well as the GPS data and a variety of other things in there, then we can always recreate the project but not have massive point clouds and other things that we don't really need for most GIS applications. And then it can be served in the way that Shane's mentioned, either through the ArcGIS portal, through your ArcGIS Online, or directly through some form of download to clients and colleagues. Next slide. So next step, just setting up your metadata to be discoverable, and there's different ways of going about that you can explore on your own. Next slide. So I'm not going to cover this. These are the slides that I wanted to pass on to you. This is our file structure arrangement with the core data on the top. Processing occurs in a separate, like say a Pix4D project file, for example, and then the data is pulled out and then moved back up into the core structure before jettison the intermediary data. All right, I'm going to take over screen sharing for just about 1 minute, just to plug a couple things, if you wouldn't mind.
All right. Yep.
All right.
Go ahead.
There we go. Everybody see that?
Yes.
Great. All right, so first thing I'll plug, ArcGIS has a blog where we include information, including a recent blog post that I put out with Shane and Andy regarding our file structure and the importance of this. So it's just something you might want to look into with searching for ArcGIS blog. The link is also on your on this presentation. Another thing I'd like to point you to is our tech notes. One of the ones that we recently put up that I'm proud of is our data management tool using Jupyter Notebook inside of ArcGIS Pro. And I'm going to show that to you super fast to show you how easy it is. It's amazing. So I already brought up ArcGIS Pro beforehand. Go full screen so I can see it. Say you create a map. You just have to go into your files, you add folder connections, go to your desktop, for example, where I just saved the script that is downloadable, by the way, from the tech notes. It's right there, one of the first hot links that is available. Go find the script that you downloaded and placed somewhere. Oh, I'm moving too fast. You can see the wheel turning. All I would do is say open notebook. Oh, fun time for ArcGIS Pro to freeze up. That used to happen all the time, by the way, when it first started. If you were too fast in your movements, then it would be stop responding. See if it works now. There we go. Open notebook. We can see the notebook. This is the download that you could have accessed again through the site. There's the first section that sets up the dependencies and it gives defines everything. So what you would need to do is you could change the base, the directory structure, the naming conventions that are all forms of metadata, and then simply run this. I set it up to run inside of the DroneCamp 2020 folder inside of data management. And what that would have created then is a data management file structure. It would have been similar to what we would be expecting. Did I set the pathway right? I don't see it yet. It might take a minute for it to complete. Huh, interesting. Anyways, what that would do is create that file structure in its entirety based upon the metadata. And that's all there is to it. And I'm going to end now because I'm over time already.
All right, yeah, thank you. We were all over time. Apologies across the board. Let's take a 5-10 minute break. Hopefully this was all useful for you. Any last things, Sean or Shane, before we wind down?
I think that,
as you can see, we're just so enthusiastic. It just runneth over, so we have a hard time.
Yeah, there's just so much to think about when it comes to data management, sharing, and how to do it well.